All right, 10.2 is using combinations and the binomial theorem. And it's a little more challenging than 10.1. The first two videos are going to focus just on combinations, so we'll get to the binomial theorem in the last two videos. So what is a combination? It is a selection of R objects from a group of N objects where the order is not important. So notice here's your R and N again, and just like a permutation, it's going to be an ordering of objects, but it's not, the order isn't going to be important. So if I line up A, B, and C, or if I do C, A, B, that does not count as two different orders. So with a permutation, these two would be different. But because the order is not important, I still have the same three letters, but the order doesn't matter, so I don't count this twice. So combinations don't have as many possibilities because of this overlap doesn't count as two, it counts as one. So it's not as many orderings as you would get with a permutation. Now the formula is very much like a permutation. So first of all, instead of a P, we use a C. Okay, so the number of combinations of R objects. So R is again, the subset of the entire group. So N is your total amount of things or people. R is how many of those you want to order. And so we replace the P with a C, so NCR. And it's still N factorial over N minus R factorial, but the denominator is also times another R factorial. So you're going to divide out the number of things you want to order if the order is not important, and that's going to cut that number down to be a smaller value than if it were a permutation when the order does matter. So I would stop and really stress, if I were taking notes right now, that a permutation is when order does matter. Okay, and a combination, which is what we're talking about in this lesson, is when order doesn't matter. And you're going to have to make that decision. So if you have a problem, and we'll do several, you're going to have to decide if order does or does not matter, and that's going to be the difference between a P and a C, a permutation and a combination. Okay, so here we go with the first example. It says you are picking 7 books from a stack of 32. If the order of the books you choose is not important, how many different 7 book groups are possible? Okay, now here, the problem tells you that the order is not important. So you don't have to make that decision on your own. If you did, I would actually think that the order probably would matter. Or I'm sorry, no, I would think it wouldn't matter because you're just stacking books. So if you have the same 7 books but in a different order, I don't think that would matter to me. However, yeah, you know, you might go both ways. So this would be a problem in which you would just be told. So how many ways can I order them? Well, I have 32 books, and I want to order, the order doesn't matter, so I'm going to use combinations, and I want to order 7 of those 32 books. So the formula says take 32 factorial divided by 32 minus 7 factorial, and then times another 7 factorial. So I'll give you a second to think about that. So 32 factorial means 32 times 31 times 30 times 29, etc., etc. But then I'm going to divide out. 32 minus 7 is 25 factorial, so 25 times 24, blah, 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 and times 7 factorial, so 7 times 6 times 5 times 4. Now again, I don't expect you, by the way, to write all of this out, as I did not just write all of that out, because that's a lot of stuff to write down. So once you write out this, I would go to your calculator. Now, it's the same spot as when you do a permutation. So 84 calculators, you have to type in the 32, and then you go to math. Okay, so you go to math, and then you go to PRB, and then you're going to choose the NCR, not NPR, so NCR, and then type 7. So type the 32 first, then go to math, probability, choose NCR, and type the 7. 89s, you're going to go to second 5, remember, and then probability, and you're going to be given NCR with open parentheses. So you type in 32 comma 7. Now when you do this, you end up getting a very large number. Let's see if I can write all of this down. All right, so 3,365,856. Now, if you type this out on your calculator, 32 times 31 times 30 times 29, blah, 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 then once you get here, the 25 times 24, that's going to cancel out with the 25 and 24 up here. So it's really going to be 32 times 31 times 30, just down to 26. And then you're going to divide out another 7 factorial after that. But again, you don't have to show all of this. That's a little excess. So this is all you need. Okay, so the concept of combinations isn't too bad, but now you're going to have some tricky problems within it. Okay, so here it says the local movie theater rental store is having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies. Okay, Part A says you want exactly 2 comedies and 3 family movies. How many different movie combinations can you rent? Now remember the fundamental counting principle said if you want exactly 1 comedy and 1 family movie, you would just take 12 times 9. But I want 2 of those comedies and I want 3 of those 9 family movies. Now, does order matter here? No. So why doesn't it matter? Because if you think about, if I go in and I select comedy A and comedy B, if I switch them around, I have comedy B and comedy A, but it's still the same 2 comedies. So order does not matter, hence it's combinations, right? So if I want exactly 2 comedies, starting here, okay, I know I have 12 comedies and I want 2 of them. So I'm going to do 12 C2, and that's going to give me all the ways I can pick 2 of the 12 comedies if order doesn't matter, hence C. Well, then I want 3 family movies, so I have 9 of those, and I want 3. So how many ways can I order 9 or 3 family movies if there are 9 to choose from? So 9, choose 3. Then I'm going to multiply those together because the fundamental counting principle says take how many possibilities here times how many possibilities here. Okay, so typing these in your calculator, 12 choose 2 is 66, and 9 choose 3 is 84. And when you multiply those numbers together, you get 5,544 different orderings of 2 comedies and 3 family movies. Okay, I'm going to stop here and I'm going to highlight the word exactly. Okay, when you want exactly something and something, that means you're going to multiply. Okay, so when it's an exact amount, you're going to multiply. If it's not an exact amount, now read Part B. It says you can afford at most 2 movies. Well, at most is not an exact amount. It's not exactly 2. At most means maybe you can afford only 1. Maybe you can afford only 2. Or actually, maybe you can't get any because 0 is also in that. So when you have a range of possibilities, so here's a range of possibilities, that means you're going to add all those combinations. Okay, so how many movie combinations can you rent? Well, notice it's just 2 movies in general. So first of all, I have to go up here, 12 plus 8 plus 7 plus 5 plus 9. I know that I have 41 movies altogether. So I could do 41 choose 2, but that's if I get 2. It's supposed to be at most 2. Or I could do just 1, or I might get none, right? So again, a range of possibilities means take all those possibilities, 2 or 1 or 0 movies, and then add together those combinations. So 41 choose 2 is 820 ways. 41 choose 1 is 41. Anything choose 1 is itself. And 41, choose 0. Well, think about it. If you have 41 movies to choose from, how many ways can you get none of them? There's only one way that that's going to happen. You're just going to walk away with nothing. So 820 plus 41 plus 1 is 860 ways. Now I'll tell you this, the one that gets forgotten is usually the 0, because people think that that's not a possibility, but it is, right? You could just walk away with no movies. So again, what are the key words here? And so exactly, an exact combination means multiply, and a range of, like at most, no more than, up to, at least, that means add. Okay, I want you to try these and pause the video and make sure you get the answer, but with the first two, really, if you aren't getting them, you need to ask me how to type those on your calculator tomorrow, and then see how you do with this one too. Okay, so checking your answers, I just have the answers for the first two, so it's really just a matter of, do you know how to type that in your calculator? And you could show the work too. This one, I'll just write out the first one is 6 factorial over 6 minus 3 factorial times 3 factorial. And then the movie rental one, you want to find the number of possible movie combinations if you can choose 2 action. So there were 8 action, you want to choose 2. And 2 dramas, so 7 dramas, and you want to choose 2. And why did I multiply? Because I wanted exactly 2 action and 2 drama. So this is an exact situation, hence I'm going to multiply. If you care about keywords, the word and always means multiply in math, so you can maybe just remember that. It's certainly up to you. And you get 588.